Hello again. So this was a question that came up in the homework, and I don't think well, I guess I'm a little surprised to even see it there, but I'm surprised at some of the homework. But in any event, let's take a look at this, right? So the endpoints of a movable rod of length 1 meter have coordinates x0, which is right here, and y0y, which is up here, that point there. And so the position of the end of the rod on the x-axis is given by this function here, right? And you can see it's a sine function, right? And that just means it's going back and forth, right? Okay. So, right, and so what happens is, because the rod is fixed, it's 1 meter, that means that this point up here, the y-coordinate, also goes back and forth. It goes up and down, right? So x goes right and left, y goes up and down, and t is the time in seconds, x is in meters. Yeah, well, it's 1 meter, so I guess it's all in meters here. Okay, well, so question A, find the time of 1 complete cycle of the rod. So in other words, right, if it starts here, actually, when t is 0, we're actually starting at x equals 0, which is right here, right? And so what happens is it goes to the right, and it goes to the left, and then it goes back to 0. So how long does it take to go essentially from back and forth, right? From one side to the other and then back again. So that's going to be 1 complete period. This is part A. 1 period of the function x of t is equal to 1 over 4 times the sine of pi over 6 times t. Okay. So the 1 over 4 gives us the amplitude. In other words, right, the maximum point here, let's say this is the maximum point, right, will be 1/4 of a meter, 0. Right, and then it just goes in between negative 1/4 over here and positive 1/4 over here, and it just goes back and forth in here. Is that, yeah. Okay, so if that's the amplitude, what's the period? So hopefully you remember that if I just do sine of theta, right, that 1 complete period of sine goes from 0 to 2 pi, right? So the period of the sine function is naturally 2 pi radians. So what happens if theta is pi over 6 times t? So in other words, that has to be 2 pi radians. Right? Solve for t. Right? In other words, just divide by pi over 6. Or better yet, right, if this is pi over 6 times t, and that's equal to 2 pi, we could divide by pi over 6 or multiply by the reciprocal, 6 over pi. So these cancel, and your period should be, let's see, the pi's cancel here too, 2 times 6, which should be 12 seconds. Right? So in other words, this rod here goes back and forth every 12 seconds. So the time to complete 1 cycle, well, try 12 seconds. I hope that works, because I think that's the answer. And then part B, what is the lowest point reached by the end of the rod on the y-axis? So, okay, so here's the point on the y-axis right here, and then this is going to go up and down as well, right? So it goes up and down and up and down. So what is the lowest point, right? In other words, what's the smallest y that this rod reaches here? So, yeah, so how do we figure out the y-coordinate? Well, One way to do that is to notice, right, that the rod looks like this. Right? We know that this is 1 meter long. This is x, right? This is 0 here, and this is y. So because the vertical and the horizontal are perpendicular, this is a right triangle. Right? So if this is x, this is y, we can use the Pythagorean theorem, a squared plus b squared equals c squared. But here, right, a is x, b is y, and c is just 1. So we just get x squared plus y squared equals 1. So that's the relationship between x and y. Okay. And what can we do with that? Well, let's continue over here. So what are we looking for? We're looking for the lowest point of y. So we could try solving for y. We get y squared is equal to 1 minus x squared if we subtract x squared from both sides. And then we could take the square root, but then we'd get plus or minus. So I would rather just take the derivative of this implicitly. In fact, we didn't have to even solve for y squared. We could have done it here too. But we're looking for the lowest point of y. In other words, we're looking for where the tangent line is horizontal here, right? So remember, if we're at a maximum or a minimum, right, the tangent line will be horizontal. In other words, the derivative of y will be 0. Right? So yeah, so let's just take the derivative of both sides here. So this is implicit differentiation. Much prefer than trying to get the plus or minus square root here, right? So what do we get? We get 2y, chain rule, derivative of y. And on the right, we get the derivative of 1 is 0. The derivative of x squared is 2x. But with respect to t, we need the derivative of x, right? And now just divide by 2y. So the derivative of y, I need space here, so I'll write it over here. The derivative of y is equal to negative x over y, where the 2's go, right? I canceled the 2's here. 2 divided by 2 is 1. X over y, minus x over y times the derivative of x. Okay, so we want to know where that's equal to 0, because that's what happens at the lowest point here. Well, it also happens at the highest point, but we'll have to figure out which one it is later, right? Okay. So let's see, how do we do this? So the derivative of x, okay, so here's x of t way up here. This is part A, right? So x of t is given. So let me just copy that down. I believe it was 1/4 times the sine of pi t over 6, right? So that's x. We know the derivative of x will be 1/4 times the cosine of pi t over 6. And then by the chain rule, the derivative of pi t over 6 is pi over 6. So let's pull that in front, and this will be pi over 24 times the cosine of pi t over 6. Okay, so that's the derivative of x. Right. And we know, we know what x is, right? It's just this, 1/4 sine of pi over 6. But what's y? So maybe we should have done that first. If we have x squared plus y squared is equal to 1, and x is 1/4 sine of pi t over 6, then x squared is that whole thing squared plus y squared equals 1. So in other words, y squared is just going to be 1 minus, and then 1/4 squared is 1/16. And we have sine squared of pi t over 6. Yep. So that's y squared. Y, of course, will be plus or minus the square root of all that, which is not pleasant. Okay. And again, now we have to figure out, is it plus or is it minus? Well, if we want it to be at the bottom, I think we want the negative one, right? So now I'm just second guessing myself. After all, if this is the x-axis and this is the y-axis, this thing is always going to be, it's always going to be up here. So it should be the positive square root. So never mind. It's always the positive square root. And to that end, we could have just taken the derivative explicitly here. But I thought it was maybe, I don't know, maybe it's more fun using implicit differentiation. So, yep, if we took the derivative of y as it is here, and I might run out of space, remember this is to the power 1/2. So you'll get 1/2 times 1 minus 1 over 16. I'm going to run out of space. There's no way I can fit that in here. So, all right, so let's do this way over here now. What's the derivative of y? So 1/2 times 1 minus 1 over 16 sine squared pi t over 6 all to the power negative 1/2. And then the derivative, by the chain rule, the derivative of what's inside is 0 minus 1 over 16 times 2 times the sine of pi t over 6. Right, the 2 is the power rule here. And then another chain rule, so another pi over 6 here. Okay, so that's a mess. Let's see if we can clean this up here. So I'll leave the 1/2 in front. We still get all of this, 1 over 16 sine squared pi t over 6 to the negative 1/2. And then negative 1 over 16 times 2 is negative 1 over 8. And then times pi over 6, I think, is negative pi over 8 times 6, 48. So what are we going to get here? We're going to get negative pi over 96 times the sine of pi t over 6 divided by the square root of 1 minus 1 over 16 sine squared pi t over 6. You got all that? And I think that would have been the same thing if we used implicit differentiation and then we plugged in the x, y, and dx over dt. Okay. In any event, that's the derivative of y. Where does it equal 0? So we can divide by the negative pi over 96. We don't need the square root. We can multiply both sides by that. It's essentially just sine of pi t over 6. Where does that equal 0? Well, let's think about sine of theta equals 0. Right? Remember the unit circle? Sine is the y-coordinate. So sine is, the y-coordinate is going to be 0 here and here, left and right. So that's 0, pi, 2 pi, 3 pi, so any multiple of pi, n times pi. Okay. So if this is my theta, when does that equal n times pi? Right. So same trick as before, multiply by 6 over pi on both sides. That cancels the pi. So t is going to equal 6 times n, where n is, I'm just using n for any integer, right? So 0, 1, 2, 3, and so on. Okay, and now we just have to figure out which n is it. So what are we trying to find? The lowest point on the y-axis here, right? So, right, so what happens, let's start with n equals 0. If t is 0, where are we? Then the rod is vertical here, right? So it's going to fit, it's going to look more like this. It's going to be, yeah, starting here, going straight down this way. So that might be the highest point, right? So I think when n equals 0, we're at the highest point. So the high point. So how about if n is 1, which means t is 6. So if t is 6, think about what x is. X is going to be sine of pi, which is 0. Wait, if t is 0, right. And if t is 6, boy, that's also 0. Okay, that doesn't make any sense. Well, I mean, that's what we get, right? So pi t over 6. Yeah, that's where the derivative is 0. Oh! I'm confusing that with x, right? X is the position, not the velocity. Right, but we're looking for the endpoint here, right? In other words, I think you can, I mean, does it make sense that when x is furthest along here, that y has to be at the smallest point, the lowest point? Because when x is in the middle, the y value goes higher here. Does that make sense? So, so we really want to know when x is 1/4. That'll give us the smallest value of y. The largest would be when t is 0, right? Or when x is 0. So why am I not getting that with the dy over dt here? So I probably took the derivative wrong. Now I realize something. So yeah, we're taking the derivative of this here. So the derivative of what's inside, you get 2 times sine times cosine. The derivative of sine is cosine. So I'm missing a cosine here. All right. So get rid of this bracket here. And I'll get rid of the pi over 6 as well. Although that's still going to be there for the chain rule. But I don't think that's going to matter. So yeah, so I'm missing a cosine of pi t over 6 times pi over 6. So yep, this is sine times cosine here as well. And so yep, just multiply by cosine of pi t over 6 here. Okay, so I took the derivative wrong, right? So it's really not where sine of pi t over 6 is 0. It's sine times cosine equals 0. And that's not as easy to solve. Here's what I'm going to do. I'm going to use the double angle formula. I hope you don't mind. Oops. This is equal to sine of 2 theta. So sine times cosine, right? If you divide by 2, then sine times cosine is just sine of 2 theta over 2. So this is going to be sine of 2 pi t over 6 over 2, which is the sine of pi t over 3 over 2 equals 0. So the 2 doesn't matter. You can multiply by 2, Yep, so it's the sine of pi t over 3 equals 0. That's what we want to solve. So pi times t over 3 is going to be, again, that's the n pi from here, right? And so t is going to be 3 times n. There we go. Not 6 times n. Okay. Well, we already know that when n is 0, t is 0, and that's the high point. So now if n is 1, we're at t is equal to 3. So I think that should be the low point. When t is 3, x is going to be 1/4. Yep. So x of 3 is 1/4 times the sine of pi times 3 over 6, which is 1/4 times the sine of pi over 2. Sine of pi over 2 is 1, so this is 1/4. But the real question is, what is y of 3? So here's the formula for, well, that's dy over d. Here's the formula for y at the bottom here. So let me, before I do that, let's write down y again. Y of t is equal to the square root of 1 minus 1 over 16 times sine squared of pi t over 6. So y of 3 is the square root of 1 minus 1 over 16 sine squared of 3 pi over 6, which is again pi over 2. And remember, sine of pi over 2 is 1. So this is just the square root of 1 minus 1 over 16, which is the square root of 15 over 16. So that's the square root of 15 over 4. So that should be the lowest point, right? The highest point should be 1. If t is 0, then y is 1. So that's the high point. This is the low point, lowest point. Okay, so the lowest point should be in parentheses, so x is 0 and y is the square root of 15 over 4. Try that. Hope it's right. And then part C, so this is find the speed of the y-axis endpoint when the x-axis endpoint is 1/8. So when x is 1 over 8, oh boy, so part C, find the velocity for y, so the derivative of y, when x is 1/8. Find the speed of the y-axis, yeah, so the speed of the endpoint when x is 1/8 and y is 0. Well, sorry, yeah, the x-axis endpoint is here, so y will be 0 always. And on the y-axis, x will be 0 always. Okay, so we need to go back and look at the derivative of y, which we did up here. And again, I'm not certain I'm right here. Remember, I forgot the 2 here. Oh, no. Okay, so this is fine. This is correct here. So let's see if I can remember that. So the derivative of y with respect to t is negative pi over 96 times sine times cosine. And remember, I was going to change that to sine of 1/2, so there's another 1/2 down here. Sine of pi t over 3, then divided by the square root of 1 minus 1 over 16 sine squared of pi t over 6. So I think I got that right. So 96 times 2 is, I think, 194? Maybe 192, I think. So negative pi sine of pi t over 3 over 192 square root of 1 minus 1 over 16 sine squared of yada yada yada, pi t over 6. Sorry about that. Okay, so that's the derivative with respect to t. So that's the velocity. That's what we're looking for. Now, what t do we plug in here? Well, that's going to be another tricky problem because they don't give us t, they give us x. So now we have to go back to the original definition of x, which was given. This was given in the problem, right? 1/4 times the sine of pi t over 6, and that is equal to 1 over 8. So solve that for t. Wow, I'm taking up a whole screen here. So solve for t. So what do? We multiply by 4, top and bottom, right? Or left and right, multiply by 4. So that gives us the sine of pi t over 6 is equal to 4 over 8, which is 1 over 2. So where's the sine equal to 1/2? Look at your unit circle. Sine is going to be 1/2 at pi over 6. Well, pi over 6, right, or 5 pi over 6. We'll just do those two. And so t will either be 1 or 5. Which one is it? Well, let's try it. If t is 1, then sine of pi over 6 is 1/2, and that'll be 1/8. So, yep, I think we want t equals 1. So when t is 1, we get 1/8. When t is 5, pi over 6, oh, that's also 1/8. I thought it was going to be negative for some reason. So I don't think it matters. We could do either one, but let's just make it, let's keep it simple. Let's plug in 1 here, right, for t. Okay. So this becomes a 1, this becomes a 1. So now, when all is said and done, the derivative of y should be negative pi over 192. Sine of pi over 3 is 1/2. And then in the denominator, we have the square root of 1 minus pi over 6 is, what am I doing? Pi over 3 is not, sine of pi over 3 is not 1/2. Sine of pi over 3 is square root of 3 over 2. Sine of pi over 6 is 1/2. 1/2 squared is 1/4, so this is 1 minus 1 over 64. And hopefully I'm not going to run out of space here. So we know it's negative. Let's see, square root of 3 times pi over 2 times 192. So I really need a calculator for that. 192 times 2 is 384. So 384. And then this is going to be the square root of 63 over 64. So square root of 64 is 8. So this is just going to be square root of 63 times 384 divided by 8, which is 48. All right. And don't take my word for it, because I could have easily messed this up here. But that should be the answer. So negative pi square root of 3. let's see. So I'm not going to be able to squeeze it in here. Oh, if they're asking for the speed, I don't think it's negative. Velocity is negative, speed is positive. So pi times the square root of 3 divided by, I forget, 48 square root of 63. But we can simplify that, right? 63 divided by 3, I think, is 21. So this is just pi over 48 square root of 21. Again, don't take my word for it here. I could have easily messed it up. Well, hang on. Maybe I can try it. I'm going to bring up, yeah, give me a second. I'm going to bring up WebAssign and see if that answer is correct. Okay, I think it's right. Wow, I'm amazed. Yeah, so to say that this was a tricky one or a difficult one is, I think, an understatement. And like I say, it was not my intention to actually include this in the homework, but now that it's in there, yeah, it's a tough one. So there you go. I hope that helps a little bit. You know, forgive the sloppiness here in my writing, but yeah, that's it. Anyways, overall, I guess I really wouldn't worry about this one. In looking at some of the other homework problems in 2.6, the shadow one, I know I did one like that in the video. The swimming pool one, we did that. The ladder, we did the ladder one. There's the winch at the top of a 12-meter building. I don't think I did that one. So that's a good one to think about as well. Not an easy one, but I think it's a lot easier than the one we just did here. And then there's one with the fish. Again, that's another triangle. There's the patrol car with the revolving light. So that has to do with angles. And we did one with angles. I think that was the ladder problem, also had angles with it. So, and then there's the security camera one, which also has to do with angles. You know. Anyways, not an easy one. So I regret having put it in the homework, but it wasn't my intention. Okay, so not an easy one. Let me just say one more thing here. So I took the derivative of y here on the right directly or explicitly here. And remember, I was going to do that implicitly using this formula here. After all, the derivative of x was not hard. That was just this, right? So that could have gone here. X was given, and then y was just the square root. So if we did all that, we would have gotten the same thing, I'm pretty sure. But in any event, yep, so that's another way to do it. All right, I hope this helps. If not, really don't worry about this one. You know, try the others in 2.6.